Hey guys, so today we're going to be doing a problem currently being asked by Apple, Amazon, and Microsoft, and the problem is Sudoku solver. Let's get to it. So the problem description is, write a program to solve a Sudoku puzzle by filling the empty cells. A Sudoku solution must satisfy all of the following rules. 1. Each of the digits 1 through 9 must occur exactly once in each row. 2. They must occur exactly once in each column. And 3. They must occur exactly once in each of the 9 3x3 sub-boxes of the grid. The period character indicates empty cells. So the first solution that I can think of is just a brute force solution, trying all the values 1 through 9 for each of the 81 cells. This would have crazy time complexity. It would be like 9 raised to the 81. But I think a more reasonable solution would just be walking through the grid and trying all the values. And then if none of them works, trying a different set of values for previously solved cells. And this would be the backtracking solution. But the way the human logic works for this is just 1, moving left to right, top to bottom, try values 1 through 9. If a value is valid, and we'll talk more about what it means to be valid, then place that value in that cell. And then if none are valid, we will backtrack, and we'll talk more about this. And what that means is we will place a different value in a previously solved cell, and then return to this cell again and try solving it with the 9 values now. So to talk about this validation, this is given to us mostly in the problem. We just need to look through the entire row, the entire column, and the entire sub-box, and we can do this by looking at all values in range 9. And we just need to check the row, and the row will always be the board changing, or the board keeping the board keeping the row constant and changing the column. We need to check the column, and the column will always be changing the row but keeping the column constant. And we need to check the sub-box, and the sub-box is a little more complicated because we want the sub-box to check, if we're at 0, 0, we'd want to check rows 0, 1, and 2 and columns 0, 1, and 2. And we can do this by saying that our row is 3 times the floor division of row in 3 plus the floor division of I in 3, and our column is 3 times the floor division of column and 3 plus the modulo of I and 3. And the reason this is good is because when we're at values 1 or 0, 1, and 2 will be at columns 0, 1, and 2, and then we'll also repeat again when we go to columns. When we're at 3, 4, and 5, we'll still be at 0, 1, and 2. So this will always move left to right, 1, 2, 3, and then this will move down 1, 2, 3. So that's that for the validation subproblem. And then for the backtracking, I talked about this previously, but when I do backtracking, I like to think of state, base cases or termination conditions, and the choices that we're making. So the only state that we're going to need to be worrying about is our row, our column, and the value we place in a cell. The base cases, there's a couple more. When we reach the end of the board, we just want to return true because we know we've done this successfully. When we reach the end of a column, we want to, if our backtracking method's called solve, we want to go to the next columns, or go to the next row. So we want to say solve row plus 1 at the first column. And then if a cell is not a period, we know it's already solved, so we can continue to the next column. So we can return solve of row at column plus 1. And then this last one is not really quite a base case. We'll reach this case or this termination condition through our logic. But if we cannot find a value 1 through 9 that works with the current cell, we want to return false. And this is our backtracking step. So the choices we're going to be making is just either moving right. So we'll do this by solving at our current row and our column plus 1, move right, and then moving down, which is just solving at row plus 1 and the first column. So yeah, let's try this on like a smaller board, because I think it'd be like really hard to do the entire 9x9 board, and see if this solution will work. So on a 4x4 board with 2x2 sub boxes, we'd be given these 4 values to start, and then we're going to start in 0, 0 because we're moving left to right, top to bottom. We'll see that this value is not a period, so we're going to move to the next column. We're going to be here. We're going to try 1. It's not going to work. It's in the row. 2 is not going to work. It's in the column. 3 will work. It's not in the row, column, or sub box, so we'll move on. 1's not going to work. It's in the row. 2 will work, so we'll move on. Then we'll try 1. It's not going to work. It's in the row. 2 is not going to work. It's in the row. 3 is not going to work. And 4 is not going to work. It's in the column. So what we'll do here is we're going to return false. We'll reset this to a period, and we'll go back to the last solved cell. And now we're going to try 3, since we've already tried 1 and 2. That's not going to work. Then we'll try 4. That does work. So we can move back to this cell, and we're going to try 1. That's not going to work. 2 will work. So now we can, because we're past the end of the column, we can go to the next row. 1's not going to work. It's in the column. 2 is not going to work. 3 is not going to work. 4 will work. 1 will work. And then here, 1's not going to work. 2 is not going to work. But 3 will work. We can move to the next column. Move to the next row because we're at the end of the column. 1's not going to work because it's in the column. 2 will work. So we can move here. We can try 1. That will work. It's not in the row, column, or sub box. So we'll move here. 1's in the row, 2's in the row, 3's in the row, and 4's in the column. So we're going to return false and return to our previously solved cell. We're going to try 2. That's in the row and the column. 3's in the column, but 4 does work. So we're going to now go back to the cell, try 1. This is not in the row, column, or sub box, so this works. And then we'll go to the last row. 1's in the column, 2's in the column, 3 works, so you can continue on. 1 works because it's not in the row, column, or sub box. 1 doesn't work, it's in the row. 2 does work. So now we're going to go to the last spot. It's not a period, so we go to the next column. And then because we're at the end of the column, we're going to go to the next row. And then because we've reached the end of the board, we can return true. So yeah, I think this is going to work. So I'm going to code this up. I'm going to save my board length, or board size, equals length of our board. And then I'm going to first solve is valid. So I'm going to pass in the row, column, and the string value that we're trying to see is valid. And we're going to just use these exact checks that we discussed up here. So we'll see first, we'll first check this row. So if board at row and then column I is equal to our string value, return false. If board at I and our column value is equal to string value, return false. And then if the board at this crazy row and crazy column is equal to string value, return false. And then otherwise, we can return true because not in the row, column, or sub box. So then last, we can implement this solve backtracking method. We're just going to pass in the row and column. I'm going to set these to 0 by default. So we can call it this way to start, and then we can change the row manually. And all we're going to need to do here is just implement our base cases. So if we're at the end of the board, so if row equals board size, return true. If column equals board size, return the solve of row plus 1 and then the first column. If the cell is not a period, so if row column is not equal to a period, return solve of row column plus 1 because we'll move right. And then we'll try all of our values now. So for I in range 1 to board size plus 1, if the cell is valid, so if is valid, row, column, and then this is a string, so string of I. then we'll place it. So the board at row column is equal to the string value. And then if we've solved the board, so if solved row column plus 1, return true. Else, so like we've returned false at some point, then we will want to backtrack. So we'll set the row and the column that we just solved to a period. And if we get to the end of this and we are not able to find a valid value, we'll return false. So hopefully if the syntax is correct, this will work. It looks like it doesn't ever change anything, and that's because we're actually returning false inside the for loop. We need to do that after the for loop is complete. And now it looks like it works. And this works. Awesome. Cool. So I hope that made sense, guys. If you had any questions, put them in the comments down below. This is a really good problem for backtracking, and I think it taught me a ton about backtracking. I hope you feel the same. I'll see you all soon. Have a good one. Peace.